The fundamental theorem of calculus is the next topic for us, and the definition is here. It's going to involve everything that we have been building up to this chapter. It will have integrals, it will have antiderivatives, area, everything. So it says if a function f is continuous on the closed interval a to b, so that just means it's a normal continuous line with no jumps or holes, and f is the antiderivative, so we are going to do the antiderivative here, then this is the answer. What we're going to do is first do the antiderivative, and then we're going to plug in the top number, and then we're going to plug in the bottom number and subtract them. That's going to give us the exact area of of any shape, but it will help us with the irregular shapes that we haven't been able to do yet. So for the first example, it's not really clear where it's shaded, but it is supposed to be shaded here. So we have this irregular shape. There would be no formula for this because the top is a parabola, so it's not a normal quadrilateral or anything that we're used to. So what I'm going to do is set up a definite integral. We're going from 0 to 2. The top is this quadratic function. The bottom is the x-axis, and here is how we have it set up. Now the fundamental theorem says if you do the antiderivative first, so we'll first do that, this term would be 2x cubed over 3 minus 3x squared over 2 plus 2x plus c. Then we're going to, after we do this antiderivative, we're going to plug in the top number first. I'm going to note that here, that I need to keep going. We're going to plug in 2 for all the x's, then we're going to plug in 0 for all the x's, and then we'll subtract those. So first, plug in 2. And then I'm going to plug in 0, and I have to subtract those. I am going to put all of the plugging in zeros in brackets because I'm going to have to subtract every term, so eventually I have to distribute the minus to everything. Okay, so here I end up with 8. 8 times 2 is 16, so 16 thirds. Here I end up with 4. 4 times 3 is 12. 12 divided by 2 is 6. Here I end up with 4. And then this ends up being a big 0 term. This is 0 and this is 0, so I end up just having to distribute the minus to the, you know what, I forgot the plus c up here. I apologize. So here plus c, and then distribute the minus, so the minus c. That's a c. All right, so I have 16 thirds. Minus 2, and then I have plus c minus c. So the c's end up canceling out, and that is something that will happen on all of these problems. And so the shortcut would be you don't really need the plus c's when you're doing definite integrals, which definite are when you have numbers here to plug in. You will need a plus c if this is the only thing you're doing. If you're doing an antiderivative and then stopping and not plugging in numbers, you need a plus c. But if you are going to plug in numbers, the plus c and the minus c will always cancel out, so those are not necessary. So I end up with just 16 thirds minus 2. That would be minus 6 thirds, so we end up with 10 thirds. Now, because we have a picture of this, I can kind of check and see if that looks right. 10 thirds is about 3.3. So what I can do here is look and see, does this look like it's about 3 1/3 units. So what I like to do is just kind of try and see how many unit squares are in the shape. So it looks like one full one there and another full one there. And then if I took this little piece over, there'd probably be a third one there. And then does that look like another third piece there? Yeah, so I think 3 1/3 is a reasonable answer. If you get something that's unreasonable, then you'd have to go back and look for a mistake.